All right, it is 9 o'clock. I'm going to get started. But before I get started with the actual lecture, let me just kind of go around the mic and speak from the other side too, because I turn it into a directional mode. So it's not supposed to pick up as well from one side, but I cannot tell which side is which side. That is the problem. So I think this is the right side, not the other side. I like people when people give directions like, turn right. No, the other right. That's a... yeah, turn right. The other right. No, the other right. All right, so I think this is the right one. The downside of doing this is it's not going to record your questions, so because it's directed to me. So what I'll do is I'll repeat your question. Most of the time I have to repeat it anyway, especially when the question comes from the back of the classroom. Okay. So let's go ahead and get started. What we'll do today is to focus on ternary and unary operators. Okay, because what we have talked about so far are operators that are really used to. Okay, addition, subtraction, multiplication, assignment. Okay, so all of those quote unquote operators are fairly common that we use already in the previous class. So what we'll do today is to introduce some of the operators that you may not have learned in CISP 300 or 301 because they are fairly specific to C or the entire family of languages that are based on C. Okay. So we'll go ahead and get started with increment. Okay, increment and decrement as an operator. Okay, and this is what we call a pre-increment operator. And what it does is it will do the same thing as this particular expression. In other words, in place of doing this, you can basically just do this. Okay. Now, I put extra parentheses around the assignment because I am particularly interested in the value of the expression itself. Now, remember, there are two things an assignment operator is going to do. It does two things instead of just one. The first thing it's going to do is to change the variable that is on the left-hand side of the equal symbol. The second thing it does is to return the value of the entire expression. But the entire expression has the value of the right-hand side of the assignment operator itself. Are we still doing okay so far with this stuff here? So what we'll do is we'll go ahead and use GDB to take a quick look at the effect of a statement or an expression like this. And this is also a good way to just kind of have a little warm up about for all the commands that we use in GDB, in G++, just so that we can compile and run the programs. So I'll just go ahead and make a new folder called increment, and we'll start to write the program. This is called pre-increment, so I'm just going to name the file as such. And this is not a C++ feature per se, it is actually a C feature. In other words, it is present in all versions of C and C++. So we'll go ahead and just use main here. And I'll also follow my own recommendation and use standard int.h whenever it is possible. So this way I can control the size or the width, the number of bits allocated to each integer. And this time I'll use x, y, and z. There are 3 variables. I will initialize x to a particular value. It doesn't even matter what it is. As long as it is a particular constant, it'll be fine. So what I'll do now is to say y equals to plus x, and then z equals to the other expression, which is in parentheses, specify another assignment. In this case, it is x gets x plus 1. Now the extra parentheses are only there to emphasize the order of operation. If you do not specify any parentheses on line 9, things will still happen in the same order. It's just, I want to emphasize we perform the addition first, and then we perform the quote-unquote inner assignment operation, and then we perform the outer assignment operation. Are there any questions about line 9? No questions? Okay. So let's try to predict what's going to happen. Let me finish this entire program first. The return 0 is not really needed because nobody really cares about the return value of main, at least not in this case. But it is just good when we have a return type of integer with a function, always return something. Okay, return something that is known. All right. So let's figure out what is going to happen here. After this statement, what do you think is going to be the value of x? That's a pretty easy one. Okay, x has a value of 5 after this. And note how I use double equal in the comments. Okay, because when I use double equal, it means it's an equality. It does not mean that I'm changing x to 5. So this is stating what I think is going to be the result after executing line 7, that x has a value of 5. What about line 8? Obviously, it doesn't change. Well, it does change x and y. So the question is, what do you think is the value of x after line 8? It'll be 6. What about the value of y? Y would have the value of 6 as well. Okay. So the term pre-increment means you are incrementing a variable first, and then the value of the expression is the value after the increment. Okay, so in this case, because x had the value of 5, we first perform the increment, which will change the value of x, so it becomes 6. And then after that, the expression itself, plus x as an expression, has a value of 6, and that is what we use to update y on the left-hand side of the equal symbol. What about the next one then? Well, let's take a look at x first. Okay, so there is an x gets x plus 1 inside the parentheses. Okay, and because of the nesting of the parentheses, we know that we have to do that first. So I think most of you would agree that x ends up with a value of 7. Okay, and the assignment operation, the inner assignment operation, will return the value of its own right-hand side, which is just x plus 1, which is 7. So that value will also be used to update z in this case. So that means z will now get a value of 7 after line 9 executes. Are there any questions about the order of operation or the meaning of the operators? Yes, go ahead.
When you do the plus plus x, you're actually like changing the value of x.
That is correct.
Okay.
Yeah, it's called auto increment. Okay, it's also called a pre-increment in this case. So plus plus x is adding 1 to x first, and then whatever the value of x becomes the value of the expression. Because plus plus x itself can be considered an expression, so it has two effects. One is it changes x, and the second one is it has a value that it returns. The expression has its own value.
So if you had just like y equals x plus 1, would x be changed permanently?
That would not change the value of x. You would just be adding 1 to whatever x has, and that value, the sum between x and 1, is temporary. It's only used to update y, but it won't actually change x itself. Yep.
The question, so the inner parentheses in line 9,
Mm-hmm.
are there for the reader to actually just understand that we're actually going to have that value changed to 7, or are they for the or the debugger to actually understand what it has to do?
Okay, the parentheses are here so it can emphasize the actual order of operation. But by the priority assigned to the operators, it will happen in this particular order anyway. So they're really here just to double emphasize, this is how things happen. Now, because we always evaluate parentheses from the inside out, whatever is nested all the way in is evaluated first. So in this case, we first evaluate x plus 1. X, before we do anything on line 9, x has a value of 6 from the previous line, right? So 6 plus 1 becomes 7. So whatever I'm highlighting right here is going to give you a value of 7. But at this point, x is not updated yet, right? Okay, so we just have a 7, and we use it to update x, which is the job of this particular expression. So after this part evaluates, then x is updated to a value of 7. But as an assignment operator, it also returns whatever value it is using to update the variable. So this entire thing returns, it gives you a value of 7. And that value of 7 is in return used to update the left-hand side of the equal symbol. So z ends up getting the same value of 7. Okay. All right, so let's go ahead and just run this and figure out whether this is what's going to happen. Okay. So it's always good to kind of have a analyze the code and figure out what you think the program is going to do, and then use GDB only as a verification mechanism, okay? Because in a test, you cannot really run GDB, so you have to understand the mechanism and be able to apply, apply your knowledge in order to figure out the answer. All right, so let's go ahead and compile this program. We'll do a warn all. It will complain about y and z being set but not used, okay? But that's okay. It's not a big issue here. -G so that we can turn on debugging. So the GDB has the symbols in order to get back into the source file, and then we have the -C to mean we just want to compile. We do not want to link in this case. So preincrement.cpp is the name of the source file, and as predicted, it complains about y and z being not used, but it is set, which means they get a value, but that value is never really used in the rest of for the rest of the program. And then the next step is to link the program. So we use -O to specify the name of the executable, which can be anything, okay, other than the source file name. You don't want to overwrite the source file with the executable, and sometimes people do that and they lose the source file. That would not be good. So make sure you don't use the source file name, which is a .cpp file. Anything else is okay, because you can always regenerate an object file if you accidentally use that one. So now we use GDB, preinc, use L to list the program. We'll put a breakpoint on line 8, okay, because line 7 is certainly not very interesting. Run the program. Now it has paused the execution on line 8. So the only thing we really want to check is, okay, what is the value of x? X is 5, just as predicted. Single step. So now line 8 has executed. We will double check the value of x, which is now 6. We double check the value of y, which is also 6. Okay, so far, things are happening the way it's supposed to. Then we single step on line 9. Same thing, we double check the value of x, it is now 7. And then we check the value of z, and it is also 7. In other words, we have just verified the equivalence of this expression here. This is basically a shorthand of this expression down here. Yep, go ahead.
What's if you set the breakpoint to line 1, it still goes to line 8 and 7?
Because line 1 is not really a line that can execute, so it will basically figure out what is the first line it can stop. Yeah. Okay, any other questions? Yep.
So let's say we had another variable down below that utilized x. It would go back to the value of 6 because that was the last permanent change?
Nope, no, x is now 7.
Okay, so the x plus 1 is a permanent change? Just like
No, x plus 1 is not, but x gets x plus 1 is.
Okay. Oh, I see.
So this part does not change x. It simply computes the sum of the value of x and the constant 1. That's all it's going to do. It won't change x. However, we utilize this value in the inner assignment. So when the inner assignment is done, x is actually changed to 7.
So if there wasn't the assignment statement right there and it was just x plus 1 equals z, then it wouldn't be a permanent change?
If it is just z equals x plus 1, then x will still be 6 when z is 7. Right. Okay. Are there any other questions about this one? This is called pre-increment because you can see the plus plus is preceding the variable that you are incrementing. And it is also because we perform the increment first and then we refer to the value of x after the increment, and that becomes the value of the expression plus plus x. Is that okay? All right. Go ahead.
So the first plus just tells you that you're adding, and then the second plus is adding 1.
You mean here?
Yeah.
No, plus plus is a single operator. So plus plus by itself is called the pre-increment operator. It's also a unary operator because it belongs to a whole class of operators that only requires one side to have a variable. So it's a unary operator like a negation, okay, except the effect is, kind of two-folded. It will first increase the value of whatever variable by 1, and then the expression has the value of the variable after the increment. Okay. Any other questions? No other questions? All right. So if there are no other questions, we'll go ahead and move on to the post-increment operator. Now, decrement is the same way. If you, instead of using plus plus, if you specify minus minus, it would be the same thing as x gets x minus 1. So the effect is decrease the value by 1 first, and then the value of the expression is the value of the variable after the decrement. Okay, so same basically mechanism. Instead of incrementing, you're decrementing. Now, post-increment is a little bit more hairy in a way, because first of all, it is very confusing. Okay, so instead of plus plus x, now we have x plus plus. Okay, x plus plus means the value of the expression is the value of x prior to the increment, but the expression does change the value of x. Okay, and I'll show you the equivalent form of this thing. The equivalent form of this is this little expression here. In other words, let me just scroll up so people in the back can see that too. Okay, so what this is doing is when you see a comma is actually considered an operator as well. Okay, it is an operator. It is, for the most part, a separator of individual expressions. Okay, but it is an operator because it can go wherever an operator is expected. So what this would do is it will first evaluate the expressions from left to right, just as it is specified here. So in this case, it will evaluate x gets x plus 1 first, which will update x, right? I mean, x will be incremented because of this. But then, as an overall expression using a comma, it will only return the value of the last expression. But the last expression, in this case, is x minus 1. So we increment the value of x first, and then we specify the value of x minus 1 as the overall value of this expression, which turns out to be the original value of x. And that is called post-increment. Okay? So we get the value first, and then we increment. Are we kind of doing okay so far with this one?
I think we need an example.
We'll definitely do an example. Okay? So we go ahead and copy the program preinc.cpp to postinc.cpp for post-increment. And all I'm going to do is to change the operators. So it becomes x plus plus here. And this one becomes the other expression, which is going to do something like this. Okay, it's almost exactly the same as before, except on line 8 we changed the position of the plus plus operator, and then on line 9, instead of just saying x gets x plus 1, I use a comma and then specify another expression x minus 1 as the value of the overall comma separated expression. Let me just kind of highlight what I mean by that. This entire expression here is a comma separated expression, where only the last expression specifies the value of this whole thing. Okay? But it does evaluate every component from left to right. So that means it will first evaluate this part here, which does change the value of x, increase it by 1, but that's not the actual value that I'll use to update z. It is the last expression. So it will use x minus 1 as a value to update z after x is actually incremented. Okay, I know it's kind of convoluted, and it seems kind of self-defeating, right? Because why would we do something like this, incrementing a variable first, and then refer to the value of the same variable prior to the increment? Well, actually, it does serve a really useful purpose in many different types of loops in C++. Okay, it's a very useful shorthand later on when we talk about loops in this class. But for the time being, we just have to understand the effect of a plus plus operator, but it's after the variable. Okay, so let's go ahead. Are there any questions? Looking at the source code. If there are no questions, I'll move on and actually run the program.
All the values are not
Oh,
being the same.
yeah, we have to update all the stuff here. Let's go ahead and do that. First line, same thing. The second line is going to be a little bit different because x will be incremented to 6 because it is still an increment operation applied to x. But y is only going to get the value of x prior to the increment. So in this case, on line 8, after line 8 executes, y gets a value of 5, not 6. Is that okay so far? Kind of? Okay. On line 9, about the same thing is going to happen. X is going to be incremented again, but z is only going to get the value of x prior to the increment, and that's going to be 6. Are there any questions about this? No questions about this? Let me just throw in one more little thing here, okay? Without really changing the effect of this program, all I'm going to do is to do this. Just to emphasize, when you have a comma-separated expression, only the last value, or only the value of the last expression is used as the value of the entire comma-separated expression. Is that okay? All right, so let's go ahead and run this program because it is now illustrating several things that we have just talked about, and it certainly looks a little bit confusing here. So we'll do a G++, warn all, pedantic, -g-c, post-inc.cpp, and it warns about, okay, let's read all of these stuff here. Warning, left operand of comma operator has no effect. It's complaining about the 2, it's just not doing anything. Hey, you know what? It's fine, okay? I just want to illustrate only the last one actually has any usefulness in this particular case. Because typically what you want to use, typically when you use a comma-separated expression, you're using things that have side effects, like changing the values of something. X++ has a side effect. Y equals to 0 has a side effect. 1 has no side effect. It's just a constant. Okay, I'm not even mentioning a variable. If you do not mention a variable, it cannot have any side effect. Or, well, because we haven't really talked about subroutines yet. All right. So the program did compile, okay, and now it's time to link it. So we'll do a G++-O post-inc.o. And now we can run the program. GDB post-inc. So once again, list the program. Put a breakpoint on, say, line 7, okay, because this time line 7 is actually kind of interesting. So we are now on line 7. Print the value of x prior to line 7. It is a 0. Single step, print the value of x again. It is now 5. So this is kind of like you're just confirming that when you have a comma-separated expression, only the value of the last expression is used. And that's why G++, the compiler complained and say, why do you bother with 1, 2, 3, 4 in a comma-separated expression here? They don't do a single thing. You guys getting why the compiler is complaining? Because it doesn't make any sense. And really what the compiler is really trying to do is to question me and say, is that really what you intended? Because it is possible that I mistyped something and I ended up with expressions that do not have side effects. Okay? So the compiler is really trying its best to help me diagnose potential problems. Okay, now we're moving on to line 8. So let's single step so that line 8 executes. And we want to find out what is the value of x. X is now incremented to 6. But the most important question is what is the value of y? Because the theory, or what I think it should do, is y should get a value of 5, which is the value of x prior to the increment operation, and that's exactly what it did. Are we doing okay so far with this particular program? Okay. And now we are ready to execute line 9. Okay. So on line 9, we are going to evaluate this expression first, which has the side effect of increasing the value of variable x by 1. So x would go from 6 to 7. After this, we evaluate this expression. X is already 7. 7 minus 1 is 6. That particular value of the last expression of a comma-separated list is going to be the value of the entire comma-separated list. So 6 becomes the value of this entire portion, and that is the value that we'll use to update z. That is the theory. Okay, that's what I think it should do. So let's single step and print x. X is now 7, and we'll print z. Z is 6. Are we doing okay so far with the pre-increment and the post-increment operators? Is that okay? All right. So if there are no questions about this, we're going to move on in the notes. But if you do have any questions, just go ahead and ask me, because that's these things can be confusing, and we'll be using all of these operators in programs later on. So it is really important to get this all cleared up as soon as possible. This part here, the last paragraph, is just kind of explaining how I was kind of sneaky, because I just slipped in a binary operator, one that has 2 sides to it, which is the comma. Okay, so a comma in C and C++ is actually considered an expression. Okay, it's an operator. So when you use a comma, it is called an expression in this particular context. In other programming languages, that is not the case. In Visual Basic, it's not the case. All right. Any questions? No questions? All right. If there are no questions, we'll move on to another operator that is unique to C++, Java, and all other languages based on C. And it's called a ternary operator. A ternary operator, as the name implies, has 3 components. And the form of a ternary operator looks like this. Okay? So I'm just explaining all the components here in text. So in the class, I just need to talk about it verbally. C is a condition. Okay? But a condition in C and C++ is really anything that can be 0 or non-zero. Okay? It can be an integer, can be a character, can be anything that can be either a 0, which is considered false, or non-zero, which is considered true. TV is just my abbreviation of true value, which has nothing to do with the hardware store. Some of you are way too young to know what is true value, but so TV is an expression. Okay, this expression will give us a value. I will only utilize the true value when condition C is true or non-zero. If C is false, I would utilize FV, which stands for false value. Okay, so each one is an expression. C is an expression, TV is an expression, FV is an expression. This determines whether the entire expression, the entire ternary operator, should evaluate and return this value, or evaluate and return this value. In terms of CISP 300 and 301, this is kind of like a conditional statement in an expression. That's basically what it is. Okay. So we'll go ahead and just kind of do an example here. Okay, we'll talk about this later, but we'll deal with this one first. All right. So let's go ahead and write a little example for this. I'll just call it turn.cpp. And once again, pound include stdint.h. So this way I can dictate the width of integers that I'm going to use here. So I'm going to use 16-bit because these are all relatively small numbers. And we'll go ahead and specify, I don't know, let's try, just use a 1x here. Okay, so this is this is what we'll do. So I will have only one variable x, and on line 7 I'll give it a particular value, and then on the next line I'm going to say x equals 2, and I use parentheses explicitly to separate the 3 components. So we have the question mark separating the condition on the left-hand side from the value, the true value on the right-hand side, and then the colon here to separate the then or the true value from the false value, which is on this side. So if I want to implement absolute value, what I'll do is to say, is x less than 0? If so, I want to negate the value of x so it is no longer negative. If it is already greater than or equal to 0, we'll just go ahead and return the value of x itself. So when you look at line 8, I'm taking the absolute value of x and store that back into x. That's all it's going to do. Do we have any questions about this? Now, if you want this to be more clear, we can have 2 variables instead of 1. So we can define y so that y stores the value of the absolute value. So this way we can re-examine x and y after line 8, just to make it more clear. Are there any questions about this? No questions?
So
Yep, go ahead.
So this in line 8, so it starts from the parentheses first. It checks the condition,
Yep.
then goes to the right side and assigns the true or false thing, and then goes assign whatever value we got in the end to the y.
Correct. So what it will do is it will first evaluate the condition, which will give you an integer value. Okay. So x is less than 0 gives you an integer value that is either 0 or non-zero. If it is 0, okay, which means x is less than 0 is false, it will evaluate and return the value of the false value. Okay. On the other hand, if x is really negative, okay, it's less than 0, this evaluates to a non-zero. When this part is non-zero, then it will go ahead and evaluate and returns the value of the true value, which takes the negation of a negative value, so it will come back as a positive value. And that's why this one little expression will do the same thing as taking the absolute value of x. Okay. Which is kind of neat, because I'm combining, I'm putting a conditional statement really into a single expression. Are there any questions about this? No questions? Okay, if there are no questions, we'll go ahead and play with this program a little bit. So save it, g++-1all- pedantic -g-c, and it's called turn.cpp. And it complains about, oh, okay, I did have a syntax error this time. So you can see when you have an error, it won't even give you an object code file. So there's no way I can link this program at this point, because an error means it's not going to give you an object code file. A warning will still give you an object code file. So this is on line 8, and it's expecting a semicolon for y. So that usually means the line before this is missing a semicolon at the end. So we'll go back to turn.cpp, go to line 7, and say, well, yep, I did miss a semicolon. Fix it.
Just a quick question.
Oh, yep.
Is there a reason why you skipped line 2 and line 6, or is that
It's just to make it easier to read, because otherwise, everything is lumped together, and it's harder to visually separate the actual action part, the part that actually does something, from the pound include and the declaration of the definition of the main subroutine. So it's really just for visual purposes. C and C++ and most languages based on C and C++, they don't really care about empty lines. In other words, other than line 1, okay, the rest of the program, I can just type the entire thing on a single line. It will mean exactly the same thing to G++, even to us, but to us, it's really hard to read, okay? So we'll go ahead and test this program. And G++ now just has one single warning, which is fine. We kind of know about that one. And we'll go ahead and link the program and run it. Okay, list the program. We'll put a breakpoint on line 7. Okay, well, maybe on line 8. Maybe line 7 is not interesting. We'll put a breakpoint on line 8, and we'll stop there. Okay, now the program has paused. And we'll just go ahead and use the value of x as it is now this time. So print x, x has a value of 6. What is the absolute value of 6? It's just 6 itself. and we want to make sure that we are not doing anything funky with y. Y had the value of 0. Single step, print x again, print y. The program works the way it's supposed to. Okay, so I want to run the program again, but this time I want to give it a negative value. Now, if you think about the program, it's always going to initialize x with a value of 6. Okay, so it would appear that I would have to go out, go to the editor, change that line, come back, recompile, relink, and then come back and test the program again. GDB does give you an ability that can save you a lot of time when you're testing something. It is a set var command or set variable command. So when you use set var, you can now say, you know what, I don't want x to be 6 anymore. I want x to be -5. And once you have done this part, x is now actually -5. So I can retest line 8 without having to go out, edit, recompile, relink, and then get back into GDB, which is a really good time saver. Okay? So now a single step, print x is still -5, but y should be 5, which is the absolute value of x. Are we still doing okay so far with the ternary operator? Yes?
Does the cisp var only temporarily make your change? So you can test it, or does it permanently?
It permanently changes the variable. Now, it does not change the source code of the program. So if I were to rerun the program again, it was just basically x would become 6 again because I actually did not change the program. I just changed the value of the variable at that particular moment. So it only affects that particular session of GDB, but if I restart the program, which is quote unquote the next session of GDB, that it will just revert back to initializing x to 6. Yep.
I saw you did something else that would be useful. You did exclamation point G++, and it just did this last.
Right. Yeah. It recalls whatever starts. It recalls the last command that started with G++. Yep.
Okay.
Mm-hmm. You can also use history, which is also a very useful command. If you just type history, it gives you the past, in this case 200 commands. So I think you can use an exclamation point with a number. I cannot remember how to use the actual. Okay, let me try that. So if I want to redo the Vim here, I'm just going to do exclamation point 196, and it just goes back to that particular command. So this is really useful when you have some really kind of long, lengthy, and really complicated command that you want to repeat, and you cannot remember, when you did it. This is actually persistent too. In other words, after you sign out and power down the virtual machine, and the next time you restart it, it's still here, which comes in pretty handy sometimes. Yep.
So how do you bring up the history list?
History.
So it's history.
Because item entry 201 is the command. Yep. In other words, I can use exclamation point 201 to rerun history itself. All right. Any other questions? This is a shell command, which is actually pretty handy. Any other questions? I thought I saw. No, that answer your question too? Okay. All right. Okay. So the next thing we're going to do is to say, okay, how can we nest stuff? So in this case, I can nest a ternary operator. Okay, I take it back. We can nest 2 ternary operators into 1 ternary operator. So when you look at this stuff here, it looks kind of like, wow, what does that really do? What is it really going to do? Well, you have to read it the same way as you would read any type of nested expression. Okay, so you basically, is asking a question. A is a condition. Okay, A decides which way to go. And if A is true, we go one way. If A is false, we go the other way. So we'll just use true, false here. If A is true, it's going to evaluate B. And if B is true, it evaluates C. If B is false, it evaluates D. And then if A is false, we go to the false value, which is the right-hand side, the parentheses on the right-hand side, which will evaluate E as a condition. If E is true, it evaluates F as an expression. If E is false, it evaluates G as an expression. Are we doing okay so far with the nested ternary operator? It's no different from applying any type of nested operator like addition and multiplication and stuff like that. It's just that you have to look at it in a certain way. We have the three components, which are the condition, the value when it's true, the value when it's false. And each one can be nested in whatever way we want. Okay, doesn't have to be a constant, doesn't have to be any particular thing, and each one can be its own comma-separated expression if we want that to be the case. Are there any questions about ternary operators or unary operators, particularly auto-increment, plus plus before a variable and plus plus after a variable? Well, I have a question. Does that have anything to do with the name C++? Absolutely. Okay, so the reason why C++ is called C++ is because it is one step better than C. I actually met the guy who quote unquote invented C++. His name is last name is Strustrup, and it's interesting. He's an interesting person, and he talked about why in C++ we do not remove all the bad things in C. Okay, like pointers and all the nasty stuff you can do with pointers. He basically said, if we had removed all the bad features of C to make C++ not backward compatible, then nobody is going to move on to use C++. They would keep using C. So he had to keep those, quote unquote features so that people have a smoother transition to C++. All right. And the rest of this slide really just talks about what I did on the whiteboard. So there's really nothing new here. Okay. Any questions up to this point? No questions? Yeah, go ahead.
That expression on top, that middle colon, what does that do? Is it
The middle colon here?
Yeah.
It's a separator between this part and this part. In other words, we have three ternary operators here. Okay, the overall ternary operator, the top level ternary operator, has these three components: the condition, the true value, and the false value. The colon is used to separate the second and the third component of a ternary operator. So this one is used for the overall ternary operator. Okay. Any other questions? Okay. If there are no other questions, we'll go ahead and move on to the next topic. This one is kind of easy, okay? In terms of syntax, it's really kind of like, wow, why would anyone use the percent symbol for this purpose? But in terms of the actual concept, it's easy, okay? It's called a modulus operator, which you will probably remember as remainder, okay? Which is about the same thing. So the ternary the modulus operator, like V mod B, sometimes we just call it mod to save time. So what it does is it will divide V by B. V is the dividend, B is the divisor, but instead of giving you the dividend in a normal division, it gives you the remainder in this case. And that's it. That's the modulus operator, which is a percent symbol in C++. Are there any questions about the modulus operator? No questions? All right. So that's why this is a really short slide. It's really just, so look at the modulus operator as division, except it does not give you the quotient after the division. It just gives you the remainder after the division. Now, as simple as it is really useful, okay? Because it can tell you whether a number is a multiple of another number, okay, for one thing. We'll deal with the modulus operator quite a bit later on in this semester. We are now moving on to general compound assignment operators. These are basically shorthand for doing certain things. So this looks really awful because because all I want to do is to express that you have some kind of operator between x and y. Okay, so that operator can be addition, subtraction, multiplication, did I say subtraction? Addition, subtraction, multiplication, and division. If I remember correctly, it can also be a mod operator. Okay, the percent symbol that we just saw a little bit earlier. And what it does is to say, instead of writing it like this, okay, this is a concrete example. So instead of saying x equals x plus 1, now we already know it is the same thing as this. But now we have a third way to express exactly the same thing, which is x plus equal 1. So when you say x, whatever operator equals something, that means you're using a binary operator, in this case a plus, except the left-hand side is going to be the same thing as this. It also applies to bitwise AND, bitwise OR, bitwise exclusive OR. So all of those bitwise operators can also use this form. Okay. It's easier to draw it on the whiteboard because I can use arrows to indicate what goes where. Okay. Okay. What it means is if you have something that looks like this, okay, I'm going to use left. Oh, that doesn't work too well. Let's try this one. Left hand side. Okay, when I use italic, it means it's just a placeholder. I'm not really talking about a variable called left hand side. I'm just using this as a placeholder. And I will have another placeholder on the other side, so left hand side here, which is going to be the same thing. And then you specify some kind of operator here. So instead of using OP, which is okay as a placeholder for any type of operator, I'm going to use something that is even better, like a triangle. Okay, there's no such thing as a triangle operator. I'm just using the triangle as a placeholder. Okay, and we'll do a RHS here for right hand side. Once again, it is in italic, which means it is just a placeholder of some kind of expression. Okay, all right. So if you have anything that looks like this, and the triangle is one of the operators listed here, multiplication, divisions, addition, subtraction, mod, bitwise exclusive OR, bitwise AND, bitwise OR, then you can rewrite this operation, and I use a different color, hoping this works out. So I'm going to rewrite this operator and say this is actually exactly the same thing as writing it as left-hand side, same thing as whatever is on the left-hand side here, triangle, which is the operator here, whatever it is, equal to, and this equal has to be just the equal symbol, and then the right-hand side. That's it. It's just syntactically, there's a shortcut to do it. Any questions about it's just a little shorthand. Why do you think in C and C++, there are so many shorthand mechanisms to do things? Laziness, or the programmers who invented C and C++ wanted efficiency. And those guys were, they were writing Unix, which is a pretty complex, operating system. So they don't want to waste the time to type something that is long, and they just want to shortcut it to something that's shorter. So are there any questions about, what we talked about here? Okay, so there are more examples. Okay, so if the original expression is x gets x divided by y, which means we keep the quotient, in this case, not the remainder, you can rewrite it as this. Are there any questions about this? No questions? This is all okay? Okay, so in the test, you might want to bring notes with you, because you may not be able to remember all of this syntactical stuff. So if you bring some notes, you don't have to memorize all of this stuff. You can just say, okay, this particular chunk of paper talks about what kind of operator. So in case you need to refer to the notes or whatever you whatever I type, whatever you write down, it's okay. Remember, you can bring anything that is either handwritten or printed prior to the test to your exams. Okay, so I would strongly recommend you guys to kind of, as we start to talk about the topics, print it out, okay, or if you want to, use your own notes. If you take notes, during the class or after, you'll bring that as well, in the exam. All right, so moving on, we are almost done. This is a quiz, so I'm gonna open this quiz, soon. Actually, it is open. And 2 people have attempted already, and because we just finished all the topics, today, that is actually the right time to have it due. So you have 1 week to finish this one.
The other quiz that due is on February 9th?
The other one is the 9th, I believe. Yeah, base conversion and bitwise operator. Yep, it is the 9th, which is the Monday. Okay, so it's 1 week from Monday, which is, we finished the topic on Monday, and that's why you have 1 week from the time we finish the topics to get it done. I don't think it would take you guys a whole week to do it, but it gives you more time to practice, okay? Are there any questions about these 2 quote-unquote homework assignments, which are basically in the quiz
are the
format?
Quizzes timed or, are the quizzes timed or?
No, they're not timed. That's why they're considered homework assignments, because you can spend as much time as, once you open it, you can spend as much time as you want to work on the questions. And I believe in both cases, you can resubmit as many times as you want. You can reattempt. Okay, you finish one, you turn it in, and you go like, well, I'm not really happy with the score. It means something. I'm missing something. Okay, I'm not getting it all right. You can do it again, and it will only keep your highest score. So that way, you can use it as a practice, as a way to practice all of the stuff that we talked about today. And you're certainly welcome to use G++ and GDB, like what I just did in class, to help you understand, the operators. But do not rely on the tools to give you the actual answer, because you will have to figure out the answers by yourselves during an exam. So in an exam, we are not going to use computers. We will not be using GDB or the other tools. It will be a paper test. Okay. Any other questions? No questions. Wow, we are moving along pretty good here. I would say warp 5 at this point. Okay, we're not quite at warp 10 yet. If I have another cup of coffee, we might get to warp 7. If I don't have my coffee, it will just be in impulse speed, sublight speed. No trackies here? Nah. All right, so I rearranged the topics a little bit. So instead of talking about control structure, which I have a reason to do that, we'll talk about libraries and modular programming. So these are the topics that we'll talk about. How many people have some exposure to the concept of a subroutine, which is usually how it's called in other languages? A subroutine, a procedure, or a function, or a module, okay, in some other cases, in your CISP 300 or 301 class. Okay? So if you did not raise your hand, you did not get any exposure to the concept of subroutines? Is that correct? Because it does make a big difference depending on the answers from you guys. Because if you have no exposure to subroutines, that really changes a lot of things that I can assume in this particular class.
Yeah, you can assume that we don't have any exposure to that.
Okay, well that will be okay. That's going to be a problem. Okay, so let me show you something first. Okay, this is it's not working. Great. There we go. Okay, what I'm showing you is called the curriculum of this class, which by all means, really should be visible to students, because you are the ones, who are going to, get the content out of a class. So you should know what is expected, from the content of a class like that. So I'm going to pop up the curriculum of CISP 300 from ARC and show you what we are supposed to do, what people are supposed to go over in CISP 300. So let's see, do you see subroutines here? Second to last. Yep, synthesize a subroutine to abstract one or more similar blocks, and I think there are more subroutines here. Okay, so we have item 4, construct a trace table, yada yada yada, and it talks about subroutines. Compare inline copy and paste coding with structured subroutines. So subroutine is a big deal. Okay, in CISP 300, at least the way I taught mine. So in mine, I talk about subroutines, how to trace the execution of a subroutine, how to deal with recursive subroutines, passing, a single result from a subroutine, and so on and so forth. So this is what CISP 300 is supposed to cover. So in other words, if your CISP 300 is not covering these topics, I need to talk to, my colleagues about that. Okay. All right, so let's go ahead and start from the beginning, and let's just try to focus on what a function is, what a subroutine is, and then I'll try my best to go over the same topics that I usually do in CISP 300, but in a kind of compressed timeline. Okay, because this is not CISP 300, I cannot spend too much time on those topics, on those concepts. In a way, it is good because, in a way, I do not trust how other people teach subroutines. Okay. Now, I do not mean it in a bad way. I simply mean that sometimes they may not emphasize something that I feel is particularly important, and they might have missed certain things that is important. Okay. So let's go ahead and start with a simple subroutine. Okay. So we'll start with. This is a typical thing that I do. It's just 5. Okay. So with a subroutine, it has several components, and I'm just going to give you a very simple example here. Well, I probably should include std and .h. So this way I can specify the number of bits allocated to everything. So this way it's consistent with what I talk about in class. Okay. There we go. All right. So we have a very, very simple program here that illustrates the concept of a subroutine. From line 2 to line 5 is the definition of a subroutine that has a name of 5. So in C and C++, a subroutine has typically 4 components. The first component is called the return type. In other words, it tells you the invocation of this particular subroutine 5 can go wherever an int32_t can go. That's basically what it's saying. Are we doing okay with that concept? Okay. The second component is the name of a subroutine. In this particular case, I chose a really kind of awkward name for this subroutine. It's called 5. Okay. F-I-V-E, spelled it out, it's 5. The third component is a list of parameters, which is optional. In this case, there are none. Okay, so that means I'm not passing any information into the subroutine. It does not need anything from the invocation, from the caller itself. And then the rest, which is the fourth component, is from line 3 to line 5 here. That's basically quote unquote the body of a subroutine. Okay, which is basically just a block of statements. Whatever you want to do, it's just a block of statement. So whenever the subroutine is invoked or called or triggered, this block of statement executes. Are we doing okay so far with that part of the explanation of a subroutine? Is that okay? Yep.
Why did you put the return 5 instead of return 0?
Because I wanted to return a value of 5. Okay, and that's why it's called 5. Okay. Okay, so this is all, collectively from line 2 to line 5 is the definition of a subroutine. Okay, by looking at these 4 lines, I know what the subroutine can do and what it requires in order to to get invoked. The invocation of 5 is on line 12, which is right here. This is called the invocation of 5 or the subroutine 5 because it is going to trigger the code from line 3 to line 5 to execute here. Now, you can see that 5 with open and closed parentheses, open and closed parentheses is inside where an expression is expected in an assignment operation. But that's okay because the return type of the subroutine, which is in32_t, is basically saying wherever an in32_t can be, you can invoke 5 in place of putting an integer that is 32-bit wide. And we can certainly put a in32_t value here because it is an assignment, and the other side is exactly a 32-bit integer too. So it's perfectly okay to invoke subroutine 5 in place of just specifying a particular value that is 32-bit wide. Are we doing okay so far? So when you execute this program, what's going to happen is on line 12, it's going to first invoke 5 because I don't know what to store in X until the right-hand side is finished evaluating. But the evaluation of the right-hand side on line 12 is going to invoke 5, which means I'm going to execute the code that is here. Now, this is really simple. All it means, return 5 means whoever is invoking me, whatever place it is now just a value of 5. Okay? So that means I now can go back to line 12 and then just say, oh, this entire thing is just the value of 5. Okay? The numerical value of 5. And that's it. Okay? I don't have anything else to do on the right-hand side anymore. And now I can use that value of 5 to change variable x to 5 as well, and it's all done. Are we doing okay so far in terms of the sequence of which line gets executed first, and then where it goes, and then all the other stuff? The magical part is when we get to line 4, when we execute line 4, it magically knows how to get back to line 12 to continue execution on line 12. Okay, so that's kind of magical. Okay. Well, nothing is really magical, but to us, it may seem magical for the time being. Yep.
Is that kind of like linking, or like the program references another?
It is not linking. Okay, linking has to do with resolving unresolved references. This is actually continuing execution inside the subroutine, and then when the subroutine is all done, it will continue execution where it left off from in the first place. So we'll go ahead and save this file and do a G++ -1 all and all that and the whole enchilada. And take -G-C 5 CPP. And it gives us the same kind of warning because I don't really utilize the value x. And then we can do the linking, G++ -O 5.0, and then we'll do a GDV of 5, okay? And we'll list the program, we'll put a breakpoint on line 12, okay? So we'll run the program, now we pause this on line 12, print the value of x just to make sure that it's not originally 5 to begin with, okay? Now when I single step, it's going to single step into the subroutine 5. So single step, and you can see that it continues execution on line 4, which is inside the definition of the subroutine. Okay? Now when we single step again, it's going to get to the end. Okay, this is the end curly brace of 5. And then when we single step again, it's going to continue execution back on line 12, because now we know what the right-hand side of that expression is. And well, it finished the whole thing without stopping once. Okay, unfortunately, it does not stop there. But when we look at the value of x, it is now updated to 5. Okay, but it still illustrates the two important parts. In the invocation, it continues execution in the subroutine, and when the subroutine is done, it somehow knows how to continue execution from where it was, from where it started in the first place. Is that okay? Kind of? Okay. So the question is, how does it know that? In other words, okay, let me make this program more complicated. Okay, let's make this more complicated by doing this. Oops. Now it is much more complicated. Now, is it a lot more complicated now? Nah, not really, right? Okay, but the complicated part, or the part that requires us to kind of think about it, is how come the first time we invoke 5, it knows that we have to continue execution on line 13, and then the second time we invoke 5, which is on line 13, it knows that we have to continue execution on line 14. Okay? In other words, it knows, it kind of remembers where we did the invocation, and it would just say, oh, we started from here, so when I'm done, I will go back to that point. Okay? So we'll go ahead and just run this program. So we'll do a history %. There's a way to repeat like a command based on offset, like the last 5 commands or the previous 5. I just don't remember how to do that. Okay, and then the other one is %206, the next one, and then 207, which is GDB. Yeah, I know. I can just type GDB. It's probably not gonna. Yeah. List the program. Put a breakpoint on line 12. Run the program. So on line 12, it's going to do exactly the same thing as last time. Single step. It goes into the subroutine. Return 5. It gets to the end of the subroutine. It continues execution on line 13, which is exactly what happened last time. But what about on line 13? If I single step, once again, it goes into the subroutine 5, continue execution on line 4, single step, it gets to the end of the subroutine, but this time when I single step, somehow, magically, it knows that it needs to go to line 14 and not line 13 anymore. So the question is, how does it do it? How does it know that? Okay, now in cisp360, when I taught that class, we use just a spreadsheet to work out all of this stuff, and people actually have to trace the program and maintain what I call a call trace. But in GDB, there's an easy way to do it too. So I'm going to rerun the program with the breakpoints. Okay. So what I do is I'm going to introduce a new command in GDB. It's called backtrace. Okay. Backtrace displays where we are in the program. Okay, which is no big deal. We always know that we are on line 12, and line 12 is inside main. So it seems like this is kind of like redundant information, that we are on line 12 of 5.cpp, and the subroutine that we're in is main. Okay, it seems like it's really just redundant information. So now we single step just like last time, and just like last time, it is now continuing execution in the subroutine 5. So let's go ahead and do a BT again. This time it is a little bit more interesting, because in addition to knowing that we were in main on line 12, it is saying that now we are in 5, in the subroutine 5, on line 4 of 5. In other words, this is showing you somehow the computer is keeping track of how we got here in the first place. And by the time you get to the return statement, so let me continue here, single step, and at this point, if you do a BT, it's going to show you the same thing. But what happens here is we are at the end of 5, and we are ready to go back to where we came from before. And it utilizes this information. Pound 1 is now telling the computer to say, oh, let's go back, but where are we going back to? We have to go back to line 12 of main. So this information is actually being tracked by the memory and also the code of a program. BT is really just a way to display all that information, but that information is tracked by all C and C++ programs. So when we single step, we are now back to line 13. When you do a BT or backtrace again, it would just say that, oh, we're back in main, 5 is gone. Is that okay? All right. So when we single step one more time, which is on line 13 is calling 5 again, right? So now we are back in 5. But when you do a BT, you can see how pound 1 is now updated. In other words, it's saying that we are currently on line 4 in the subroutine 5 inside this particular source file, which is 5.cpp. But where did we come from? We came from line 13, not line 12 anymore. So when we are ready to return, when 5 is all done and we are ready to return back to where we came from, it knows this time we have to go back to continue execution on line 13, update Y, and then move on to line 14. Is that okay so far? I mean, does everybody kind of understand the mechanism, how we actually remember where we came from, and as a result, we know how to get back to continue execution? Okay. Well, maybe this works really well when we have one single subroutine. What about, having 2 subroutines? So we'll go ahead and change the program again. And this time, I'm going to introduce something really complicated here. We'll call it 10. And we'll do this. Okay. So we'll call this 10, and 10 is going to do this. 10 is going to say return 5 plus 5. And then in here we'll say 10. Okay? So this program is now a little bit more complicated than before. In fact, I'm going to take out line 17. Okay? I'm going to remove that because it's not going to do anything that we haven't done before. But when we invoke 10, okay, it's going to go to line 10. But line 10 doesn't really know what value to return until the right-hand side, 5 plus 5 is all done. So what it's going to do is to invoke 5, come back with a value of numerical 5, which is on the left-hand side of the addition. And then we have the other one, and it will invoke 5 again. In other words, the program doesn't say, oh, 5 is 5, so if 5 is returning a numerical value of 5, I don't have to do it again. It will do it anyway, okay? Because every time you invoke a subroutine, it can potentially return a different value, even though, it seems like you should return the same value. Okay, so let's go ahead and play with this program and see what happens. So pound 2, 1, down 2, 1, 1, and GDB 5 again. All right, so this time we'll put a breakpoint on line 17 again. Run the program up to line 17, print Y just so that we know Y doesn't really have 10 initially. Single step. So where are we at this point? Now it tells you that we are in the subroutine 10, okay? But if you ever forget how we got here in the first place, BT, okay, backtrace. So now it's telling you that we are now on line 10. Okay, the current execution point is line 10, which is in the subroutine 10, but we came here from line 17 of main. Is that okay? Just like last time, right? Okay. But what is kind of fun is when we single step again from 10, it will tell us, oh, we are now in 5, because 10 calls 5. It invokes 5, right? So when you do a BT, it now has 3 entries, because it is telling us that we are now currently on line 5 of, well, this is kind of coincidental. Okay, I did not plan it this way. We are currently on line 5 of subroutine 5 in 5.cpp as a source file. So those 5s have all different meanings. Okay, this 5 is the name of the subroutine. This 5 is the name of the source file, and this 5 is the line number. Okay, just to make sure that we understand. Okay, it is just coincidental that we end up with 3 5s of pound 0. Okay, but how did we get here? We got here from line 10 of the subroutine 10 in 5.cpp as a source file. Now, how did we get there? We got there from line 17 in main of this particular source file, same source file. Are we doing okay so far? And you can see how the program is actually keeping track along the way. Every time you invoke, every time you call a subroutine, it keeps track of how or who, where it was called from, so that when the subroutine is all done, it knows where to get back to. Are there any questions about this mechanism? No questions? All right. Yep, go ahead.
Just actually a random question. Doesn't have anything to do with this, but I was just curious. Like we use subroutines actually to do like it's a function to get different values every time. Like we are running a program, so we would, for example, we have like a function that would, for example, multiply or divide or do an addition. But essentially, if we want to just keep having the same return, why don't we just declare a value of that return? And
Oh, because I want to, this is just for illustrating the mechanism of invoking a subroutine and returning. That's all I wanted to do.
okay, I see.
Yeah, I know this program is kind of stupid because, in the end, did I do anything with the value of 10 or the value of y? Absolutely not, right? So the only purpose of this program is really just to illustrate the mechanism of invoking a subroutine and returning from a subroutine. Okay, and it's not the program that is important. The program is like not. I mean, if you give the program to someone who does not understand C or C++ at all, they can still figure out what is going on, right? I mean, because I named the subroutines, 5 and 10, and 5 plus 5 is 10, right? But the most important part is what we did in GDB, okay? Because what you saw in GDB is the runtime behavior of this program, and that is the important part, okay? We don't have really a whole lot of time left, but what I do want to do is to show you something like this. Okay, so I'll show you factorial, factorial.cpp, and this is a fun one. This is really a kind of a cool one, and I'll explain it next Monday, and hopefully you guys will spend some time to kind of think about it, and potentially use GDB to take a look at what happens when this program or when this subroutine is invoked. So this is really, really important. Okay. So this time we have a parameter. I just call it n here. And I'll say return if n is greater than 1, it will return n times f of n minus 1. If not, it will return just 1. And then we have main here. Now you can also see that every time I define main, it's just int and not int 32 underscore t. I did that for a particular reason, okay? Because int is native to the platform. So if I'm on the 32-bit platform, int is 32-bit wide. If I'm on the 64-bit platform, it is going to be a 64-bit integer. I take it back. Main is a very special function, okay? The return type of main is tied into the default type of integer. In other words, it would not let me change the return type of main, okay? So main has to be the default integer type of whatever platform that you're using. So there's no way for me to change this one. So int32 underscore t, x, which is just a local variable, and I'll just say f is f of 3, and return the 0 here. So f as a subroutine is actually just calculating the factorial of n in this case. So I would spend a little bit of time, I got about a minute and a half here. This is the part that has been missing in the previous program. It is called the parameter of a subroutine. Okay? A parameter of a subroutine is a way for the invoking code to specify, quote unquote, the input into a subroutine. So in this case, because f is supposed to be computing the factorial of something, how do you specify which number's factorial it is supposed to compute? Well, the parameter, okay? The parameter will serve that purpose. But who gets to specify the parameter? The invocation, okay? The call to f. So you can see the invocation is f3 in this case. So what happens is the argument of 3 will now be used to specify the parameter n. So when f is invoked using line 12, n will be 3. Is that okay? Does everybody see how 3 is linked to parameter n? But the mysterious part of this program is if n is greater than 1, I will call f again from inside f. So the question is that okay? we're inside F, we're not done yet. Can we invoke F again? And the answer is yes. I have 20 seconds left. I have 20 seconds left, and the only thing I want to mention is go ahead and trace this program. Okay, single step, and you will see that we can see multiple F, in BT. Okay, as you single step, you will see, oh, here's one invocation of F, here's the next one, and here's the last one on top of that one. Okay, so you will definitely see that. And then the second thing is, look at subroutine F as a U-Haul truck. Okay, now a U-Haul truck can be just sitting in the lot of U-Haul doing absolutely nothing, right? Just like what we are seeing here. On the other hand, a U-Haul truck can be rented by someone and say, I'm moving. Now, what happens here is we are renting a U-Haul truck, and the first renter of the U-Haul truck is line 12 of main. But when we get into the factorial itself, or when we get to line 5, we are subletting the U-Haul truck. In other words, the number of U-Haul truck is only 1. But the number of people who are quote unquote utilizing the truck can be more than 1, because you are subletting the truck. So you rented the truck first, and then somebody saw you with a U-Haul truck and say, you know what, I need a U-Haul truck to move something. So can I sublet the truck, and then I'll return it back to you. And you say, sure, okay. So you basically sublet the truck to the first person. So when the first person is driving the U-Haul truck around, the first person will meet a second person. The second person says, hey, I can use a U-Haul truck today too. Can you sublet the truck to me? So now you have a second subletter of the truck. It's pretty much the same thing here, okay? The subroutine is the U-Haul truck. You only have one single U-Haul truck. But at the same time, there are 3 contracts, okay? Because there are 3 people who are actually, quote-unquote, using the truck. So if you think about it that way, it will clear up the concepts, okay? It will clear up the concepts because you don't have to return the truck back to U-Haul first before the second person can use it, because the second person is going to return the truck to you, and then you return the truck back to U-Haul. Okay? Okay, so that's all I'm going to do today. In the lab portion of today's class, I will trace this program and kind of explain it. Okay, so if you can stay here during the lab time, I think it will be beneficial. I will try to record it. I did not record it on Monday because I forgot to press the enter key. I typed out the entire command and then I forgot to press the enter key. So that's why you only got a text trace of what I did on Monday. So I'm going to stop the recorder now.